Hey guys, in this section we're going to be finding the vertex of quadratic functions. All right. So in the previous sections we talked about the shape that a quadratic function makes, and we learned that the name of that shape is called a parabola. Well, parabolas always have a lowest point or a highest point if the parabola is upside down. And this point where the parabola changes directions is called the vertex. Okay. So depending on how your equation is written, there's going to be two different ways that you can find the vertex. So if your quadratic is written in vertex form, which is here, okay, you can simply look at your equation and take into account the horizontal and vertical shifts, and that will be where your vertex is. So remember, we learned that our horizontal shift is on the inside of the parentheses, and you always take the opposite of the number that's in there. And your vertical shift is a number that occurs on the outside of the parentheses. So your vertex is always signified by HK. All right. Now, if your equation is not written in vertex form, if it's written in standard form, okay, you can't just look at the function and tell where the vertex is going to be. You're going to have to use the vertex formula. So vertex is still represented by H and K, but to find H, you're going to do negative B over 2A. And to find K, you're going to plug in H into the function, okay? And your A and B come from your coefficients of your function, okay? So we're going to do a couple of examples where our equation is written in vertex form, and we're also going to do a couple of examples where our equation is written in standard form so that you can see the difference. So let's look at this first example. So it says, find the vertex of the quadratic function. Okay. So when you guys are given these types of problems, I want you to be able to identify what form your function is given in. So as we look at this is given to us in vertex form. Okay. So since it's given to us in vertex form, we can simply look at the equation, identify what the horizontal and the vertical shift is, and then we can determine where our vertex is. So vertex is always represented by H and K. All right. Our H will be the number that's inside of the parentheses, and K will be the number that's on the outside. So remember, for your horizontal shift, if there's a negative 2 in there, your H is going to be the opposite sign. So for this one, it would be positive 2, and you're going to take K. So your vertex for this problem is 2, 3. Okay. So no other work involved. You can simply tell where the vertex is by inspection. All right. Let's look at another problem. So once again, if we're looking at this, we want to determine what form our quadratic is in if we're asked to determine where the vertex is. And if I'm looking at this is also in vertex form. Okay, which means that I just need to identify what the horizontal and the vertical shift is. So our vertex is represented by H and K. H is the number inside of the parentheses, and K is the number on the outside. So for H, remember you're always going to take the number out using the opposite sign. So since there's a positive 3 in the parentheses, you're going to pull out a negative 3, and K is negative 4. So my vertex is negative 3, negative 4. Cool. All right, well, let's look at some examples where our function is not given to us in vertex form. So if we're looking at this equation and we're asked to find the vertex, this is given to us in standard form this time. Okay, and standard form is always f of x equals ax squared plus bx plus c. Okay. So in order for us to identify where the vertex is, we're going to have to first identify what A, B, and C are. So A, B, and C are our coefficients. A is our leading coefficient, which is 1. B is negative 4. And C is positive 4. Okay. So vertex is still represented by H and K. Okay. To find H, we're going to use the vertex formula, which says negative B over 2A, and K is f of H. So we just identified what A, B, and C are, so we just need to plug them into the formula. So for us, H is going to equal negative 4 all over 2 times 1. You're going to simplify it. A negative times a negative is positive, and 2 times 1 is 2, and 4 over 2 is 2. So our H is 2. And to find out what K is of the vertex, we're going to plug 2 into the function. So everywhere that I see an X, I'm going to put 2 in its place. So 2 squared is 4. Negative 4 times 2 is negative 8 plus 4. So 4 plus 4 is positive 8 minus 8. That's 0. So my vertex is 2, 0. Okay? So a little bit more work than just by inspection, but still not that hard. All right, let's look at another example. All right, so same thing. You always want to identify what form your quadratic is given in. So once again, this quadratic has been given to us in standard form. Okay, and once again, standard form is f of x equals ax squared plus bx plus c. So we need to identify what our coefficients are. So a is 2, b is negative 4, and c is 5. So to find vertex again, vertex is represented by hk. H, to find it, is negative b over 2a, and k is f of h. So we're going to take the coefficients that we found and plug them into the formula. So it's going to give me negative 4 all over 2 times 2. A negative times a negative is positive. 2 times 2 is 4. 4 over 4 is 1. And then I'm going to plug in 1 into my function to find k. And I'm going to put that 1 everywhere I see an x in this function. So 1 squared is 1 times 2 minus 4 plus 5. 2 plus 5 is 7, and 7 minus 4 is 3. So my vertex for this problem is 1, 3. Cool. So now you should be able to find the vertex either by inspection or by using the vertex formula.